Hi guys, welcome back. So last week we looked at linear molecules, which is straight straight molecules with 180 degrees between them. This is what happens when you have two regions of electron density around the central atom. So you have a region here in the bond and you have a region here in the bond. These are normally double bonds. Like CO2 has got a double bond, but with hydrogen cyanide you've got a triple bond and you've got one single bond with the carbon to the hydrogen, and you've got triple bond from the carbon to the nitrogen. So two regions of electron density, they spread out 180 degrees as far away as they can get from each other. Because remember, these electron dense regions want to spread out as far as possible. The next shape is trigonal planar. Looks like this. It's a flat molecule with 120 degrees between the electron dense regions, or between the bonds. So this is when you have three regions of electron density around the central atom, and all regions are bonded. Okay, so this happens like with the boron trifluorine. So you have one boron molecule and three fluorines. This would look like this, or something like this. This is called formaldehyde, or it's also called methanal. But this is where this will be a double bond. So your carbon's in the middle. You've got the double bond to the oxygen, and you have two hydrogens coming out here. We count up how many electron dense regions. Double bonds count as one region, and they spread out to make 120 degrees. So this is trigonal planar. Can you write these notes in your books? Trigonal planar, this is the second shape. So pause the video, write down those notes, and we'll go on to the next molecule. Tetrahedral. This is probably the most complicated one we have to learn, because it's four regions. And when four regions try to spread out as much as possible around in a 3D space, you get something like looks like this. It's not 90 degrees as you might expect. It's 109.5 because they can spread out a bit more once you make the molecule 3D. It looks like this. So you kind of have like a pyramid base with one pointing straight up. This is really common in molecules like methane, CH4, and tetrafluorocarbon, which is this one. So these will be your fluorines or your hydrogens around a central carbon. Carbon forms four bonds, and so you've got four electron dense regions around the central atom. All the regions are bonded, and you've got the bond angle of 109.5 degrees. It's important that you remember this bond angle as well as all the others. So you've got 180 degrees for linear, 120 degrees for trigonal planar, 109.5 for a tetrahedral. So again, pause the video, write down these notes. Very important for the end of the year when it comes to your study. So we've looked at when two regions are bonded. We've looked at when three regions are bonded. We've looked at when four regions are bonded. Now we're going to look at some of the shapes. Since four regions is all we can have, we're going to look at some when it comes to only some unbonded regions. So this is the new shape, trigonal pyramidal. So it's a pyramid, and it's got a trigonal base, triangle base, so we call it trigonal or trigonal pyramidal. This is when you have four regions of electron density around the central atom. Three are bonded, and you've got one non-bonded lone pair of electrons. So you've got two electrons hanging out up here. Let's pretend this is nitrogen. So you've got your nitrogen here, and you've got your three hydrogens. You've got two electrons hanging out here, because that's how nitrogen gets its 8 electrons. We've got two up here, two in each of the bonds. So that is our molecule. And we've got one non-bonded lone pair of electrons here. This lone pair still counts as an electron dense region because it's got electrons in it. And so it looks like this, since we can't actually see the electrons, but they're pushing these atoms downwards. So the three bonding pairs determine the shape of the molecule, meaning it's trigonal pyramidal opposed to tetrahedral, and the bond angle is still 109.5 degrees. So you can pause the video and write these down in your books. I realize this is a lot of notes, but I hope you guys can follow along with it. And the last shape we're looking at is bent. This is the last shape we have to know. This is where we have three or four regions of electron density. We could have either. around the central atom, and we only have two of the regions are bonded, and we can have one or two unbonded ones. So this is like water. This will be our oxygen with our two H's, so H2O, and it's bent because we've got the electrons up here, the two lone electron pairs, causing the shape of the molecule. Okay? So we need to be able to count up our pairs of electrons, our bonding pairs and our unbonding pairs, and we need to see what the shape they're going to make. So this is our bent 3 regions. It's the same as bent, but this is a molecule like this. This is an uncommon one, so I don't think we'll see this very much. But if this is a molecule, you can see it. The lone pair of electrons will cause the bending shape, and it's 120 degrees. Okay. So finding out the shape of the molecule, how we do it. We draw out the lowest structure. So you guys can all draw out the lowest structure now, which is fantastic. Count the regions of electron density around the central atom. Double and triple bonds are just one region because they're all together. Determine how these regions will arrange themselves. We call this electron cloud arrangement. So if we have 2 regions, it will be linear. 3 regions, it will be trigonal planar. 4 regions will be tetrahedral. So that is just 3 possible combinations of this. Count the number of bonded and non-bonded regions to determine the shape. You can look at your notes and realize what type of shape it would be, and then we can draw the shape in 3D. And this is what it looks like. So this is our lowest structure for methane, CH4. It's going to look like this, and we're going to draw it in 3D like this. This is how we draw molecules in 3D. If it's in line with the page, like these 2 bonds here, going straight up and straight down, we just draw them as lines. You see this hydrogen's coming towards us? We draw hydrogens coming towards us, or any atom coming towards us, with this type of drawing. It looks like, it starts off small, it gets bigger, and it's shaded in. If it's going away from us, like this hydrogen in the back here, we just draw it as dotted lines. This is how we draw our shape in 3D. I might make some notes on this tomorrow, but I think I'm going to end the video now. And yeah, look at the task I've set in Google Classroom, and have a good day, guys.